All right, this video is for Math 2150, and it's going to focus on section 4.3. And before we start talking about definite integrals for section 4.3, I want to try to link this and connect this to 4.2. In 4.2, we looked at Riemann sums, I know that, but we also looked at finding area under curves, or not necessarily curves, but area under functions using shapes. And so I want to take a look. This is the very first example I gave you for section 4.2. I asked you to find the area of 1 plus x from 2 to 5. Okay, and so I've got the 1 plus x line up here clearly. Okay, this is the 1 plus x line, and we are looking at this function from 2. So this is 1, 2, 3, 4, and 5. We're looking from 2 to 5. And so we've already done this problem, so I'm going to kind of go through it quickly. That is a trapezoid. And so in order for us to find the area of a trapezoid, we need to cut that trapezoid into two figures. So if I go right here, I now have the area of this piece, and I have the area of the top piece, okay? And so the area of the bottom is at the area of a square. And so that means base times height. And so the area of that bottom piece, guys, the base was 3 units. The height was also 3 units. So that means the area of that bottom piece, guys, is 9. Okay. The area of the triangle that we talked about, so the base is still 1, 2, 3. Oh, but the formula is 1/2 base times height for triangle. I'm sorry. And so the area of the triangle will be 1/2 the base, which we said was 3. The height is also 1, 2, 3. So we said that area equaled 4.5 when we did the calculations. And so we said the area of the total equaled 9 plus 4.5, which equals 13.5. And I want you to remember that because that will come up in just a minute, okay? So let me transfer that over here to the knowledge that we've got about this definite integral. So first off, it's considered a definite integral because I define it from 2 to 5. So that 2 down there, guys, is called my lower limit. And that 5 up there, in this particular case, is called my upper limit. And that's where I'm bounding it by. So I'm defining it from 2 to 5. So if I look at this particular example, I'm going to integrate this function like always. So if you take the antiderivative of 1, the antiderivative of 1 is x. The antiderivative of x is x squared plus 2. How did I get that? Because remember, you add an exponent. So 1 right there. If you add 1 to 1, you get 2. So it's x squared over 2. So that is the antiderivative. And when we were doing indefinite integrals, if you remember from 4.1, you'd put a plus c. Well, we're not going to put a plus c anymore because we're defining it. So where are we defining it from? We're defining this integral from 2 to 5. Okay? And so what does that mean, you may ask? Okay, well, it means that we're going to plug in a 5 everywhere we see an x. So that will be 5 plus 5 squared over 2. And then we are going to subtract, guys. And now we're going to plug in a 2. So it'll be 2 plus 2 squared over 2. Okay? And so if I do the math, that is 5 plus 25 over 2 minus 2 plus 4 squared over 2. Or 2 squared, which is 4 over 2. I'm sorry. And so then I see a lot of kids make a mistake because of this minus sign right here in the middle. Guys, we're going to make that negative, or we're going to distribute that negative to both terms. So if I bring this down real nice and neat, I now have a negative 2 and a negative 4 over 2. And some of you are probably like, why is she not changing negative 4 over 2 to a whole number? And the reason I'm not is because these two have a common denominator, which means I can put them together. And so if I take a look at this, I've got 5 minus 2, which is 3. And 25 over 2 minus 4 over 2 is 21 over 2. And that's 3 plus 21 over 2 is 10.5. And guys, guess what? 3 plus 10.5 is 13.5. Oh, that was also 13.5. And so what I hope you just realized is when we are finding the area under any curve or function, we simply are finding the antiderivative and plugging it in an upper bound and a lower bound and subtracting the two. Okay, so let me give you another example to try to make you feel more confident in your skills. So if I do, let's do 3, oops, I don't know what happened there. 3x squared plus 4x minus 5. And let's integrate that from 1 to, let's say 4. Okay, we're going to integrate that with respect to x. So here's a really good example. Let's get started. The first step is we're going to find the antiderivative. So the antiderivative of 3x squared is 3x cubed over 3 plus 4x, add 1, so it'll be 4x squared divided by 2 minus 5x. Okay, so that's the antiderivative. We added 1 to the exponent, we divided by the exponent. I prefer to clean that up a little bit. So if we clean that up, 3x cubed over 3 is just x cubed. 4x squared over 2 is just 2x squared. And minus 5x is just minus 5x. Okay, and now we're going to integrate that from 1 to 4. And so what does that mean? That means everywhere we see an x, we're going to plug in our upper bound, and our upper bound is 4. So it'll be 4 cubed plus 2 times 4 squared minus 5 times 4. Minus, subtract. Okay, so now plug in your lower bound. Your lower bound is going to be 1 cubed plus 2 times 1 squared minus 5 times 1. And guys, from here, we just have to be careful with our arithmetic, okay? We have done the calculus. This is just arithmetic. 4 cubed is 64. 4 squared is 16 times 2 is 32 minus 20. That's my first bracket. Minus, now let's go get our second bracket. 1 cubed is 1. 1 squared is 1 times 2 is 2. And 5 times 1 is, that's a negative 5. And so since these are simply just integers in both brackets, you may want to just combine your brackets. So 64 plus 32 is 96. And 96 minus 20 is 76. So the first bracket is 76. Your second bracket is 1 plus 2, which is 3. 3 minus 5 is negative 2. So your second bracket is negative 2. And when you minus a negative 2, guys, you are going to get addition. So we have 76 minus a negative 2, which is a 78. And so for those of you that are picture people, that means if we were to graph this quadratic and find the area between 1 and 4, the area would be 78 units. Okay? And so that's another example of a definite integral. Hope this helps, guys.